how do you, from the different backgrounds that you come from, how you understand your different backgrounds. Now, how do you put yourself in a good place, in a better place, to break down this real life problem and design a machine learning system? In the end, really, that's the whole point of all this. So just trying to get all the information that is from different places, like the technical information, the business problem information, try and merge them together and see, okay, this is a machine learning system that will be useful to maybe help me optimize my business, to cut costs, and all these use cases that we've seen. Okay? So here they're trying to define supervised machine learning. So as per wiki, I think this is Wikipedia, in supervised learning, each example is a pair consisting of an input object, typically a vector, and the desired output, also typically a supervisory signal. So just like we said earlier, an input, before we had said an input object, they were referring to it as a set of features, and then a desired output value, this was a set of labels. So supervised machine learning, through historical data, is able to hunt for correct answers, and the task of the algorithm is to find them in the data. So supervised learning is a task of deducing a function from the labeled data, making prediction based on evidence in the presence of uncertainty, and identifying patterns in given data with adaptive algorithms. So really, they're just trying to, again, define what machine learning is. So they say it is a task for deducing a function from labeled training data. Like we had seen, we're going to use labeled data to deduce a function. That will be a model. And then it is going to be making predictions on evidence in the presence of uncertainty. Okay, like these predictions are going to be based on evidence because you've given it already existing examples, which is the labeled training data. But of course that those examples don't incorporate, like they're not true for every scenario, so it will still be in the presence of uncertainty. Okay, and then we want to also identify patterns in the given data with adaptive algorithms. Okay, so we're really just trying to identify, okay, what is the pattern? With all these examples that we give a model, what is the underlying pattern? And that more, as you give it more examples, it is going to be learning more. That means it is an adaptive algorithm. All right, so this is just a graphic showing supervised machine learning. Okay, so predicting values with known targets. Okay, user inputs with known answers to learn thereafter. Machine uses information to do commendable and sustainable guesses. The basis, what has happened will get repeated in the future without much drastic change, provided all the factors remain constant. So like you see, this is just their approach at defining supervised machine learning. And then from there, we see that it is broken down into regression and classification, like we had already seen. And what regression is estimate continuous values for a real output. So before we had said the regression was estimating the output being numerical or a number. But that is the same as a continuous value, like numbers are continuous, okay? For classification, the output is in a unique bucket. So we had said that the output for classification is going to be categorical. So yeah, categories, booleans, true or false, discrete values like cut, not cut, or categories like it belongs to different stipulated categories or buckets, okay? So in supervised machine learning, each example is sorted in a pair consisting of an input object and a desired output value. An algorithm in this domain analyzes the training data and provides an inferred function, which can be used for mapping new examples. So the training data consists of a set of training examples. So again, they're trying to drive the point home that in supervised machine learning, each example, the data that you use to train your model consists of, it's paired. It has an input object and a desired output. So it has, like, for this set of features, this is the exact known output. So given those labeled pairs, all that data with the known output value. You train your model, and then an algorithm in the domain, in this domain, analyzes the training data, which is that labeled training data, and produces an inferred function. So this inferred function is the one that is going to be used to map new examples. So you're just saying that, okay, I'm going to get a model, I train it on different examples, like we said earlier for the housing prices. So different houses, this is their price. Give them several examples. So now I train my model. That model is the inferred function they're talking about here. And then now for a new example, I say, okay, now this is another house that has this many rooms, this size of a garden, and this size of a house. What is its price? So it is going to, the model is going to use, the model, which is that function, is going to, has learned from the different examples that you already provided it, and that is training it using those examples. And then it is going to give you an output based on how it has learned from the data you gave it. Okay, so how supervised machine learning works. So the process of supervised machine learning is basically a two-step process as below. So learn a model using the training data, or train model using training data. Okay, the nomenclature used here is quite funny, but really they're just trying to say for supervised machine learning, it's really a two-step process. If you break it down at a high level, the first process is trying to getting the model to learn. So then in that process, you're training the model using training data. You will keep using these words as you'll see. Then the second process is testing. You want to test the model using unseen test data and assess how the model is going to perform. So that is assess the model accuracy. So you're going to give labeled examples, which is like the training data, and then you train the model. And then the model is going to be a function. So now then you give the model other examples, the test data, which don't have you know the outputs for those examples, the testing, but you want to see what the model will spit out. Then you compare those known outputs versus the model's outputs and see how has it performed. So at a high level, really how supervised machine learning works, or I guess any other machine learning works, is that you train the model, which is the learning phase, and then you test the model, which is trying to evaluate its accuracy. Okay? But then there's detailed steps that you go through. So the detailed steps for supervised learning processes are included but not limited to not limited to the process that I'm going to describe here. Yeah, so really I think this process that they're going to describe, it can be customized according to what you're trying to do, but most of them are really what you do when you're trying to do any kind of machine learning, really. So for starters, you want to prepare the data, and I believe this is what they've been teaching, or you've learned it in the previous classes. Preparation data preparation is crucial for any data analysis. If your data is messy, there is no way you can make sense of it. So really, it's just like computers, garbage in, garbage out. If you give it messy data, it will just also give you messy results. So it is very critical for you to prepare your data. Some people call this process exploratory data, I think, analysis, EDA. Yeah. There's different terminologies used for this process, but really at the high level, the gist is that you're trying to prepare your data. If it is messy or anything, you're just trying to prepare it, know it, prepare it, and then get it ready for an algorithm. Then the second step is that you're going to choose an algorithm. So choosing the most appropriate algorithm for a specific problem is the most crucial task here. So there are many algorithms, as you'll find, that you go for different blogs, different tutorials, different books. There's so many algorithms. But how do you know what algorithm suits a specific task? So that's a very crucial decision to make. Okay. So once you've chosen a model that suits your purpose, you're going to fit that model. So you're going to start using this language, you're going to fit that model. So model fitting is the procedure that takes 3 steps: function, error function, and parameter to minimize the difference. All right, so fitting is a procedure that model fitting is a process that takes 3 steps. So you get a function, then you get the errors from that function and the parameters to minimize the errors. So I'm not going to delve deep into how fitting the model works. So we're going to use already existing models. This is the point of research, really. I would expect, like, go ahead and see like what goes through, what is this process that a model goes through when you're fitting it, okay? But at a high level, when you're fitting the model, you're just trying to give it training data, and then later we shall see that we're going to assess that model. So like we said here, in supervised learning, you're going to give it labeled training data. All right, so the third step here will be choose a validation method. Depending on the nature of the data, choosing a validation step here can be the most important step. So there's also a load of evaluation methods. I'm going to talk briefly about how to evaluate your models after you've trained them. Just a brief introduction to get you as a starting point of your research, because basically I don't think I'm going to talk about everything or exhaust anything. So mostly this is just guidance and a starting point of your research. So we've said the process will be you prepare your data, you choose an algorithm. So in this case, since we are learning about supervised learning, we're going to look at the different algorithms that lie under supervised learning. So we've already seen that they fall under 2 categories. That's regression and classification. And then after choosing an algorithm, you're going to fit your model. So you get the training data and then try and fit your model. So you're going to get a model there. Then now, after getting that model, the results that it has, how accurate are they? So this is the 4th step, choosing the validation method. How do you evaluate the results of your model? How can you say that this model is this much percent accurate, like 90% accurate? That is, you're validating it, okay? Then this step is test, update, use model. Examine the fit and update until you're satisfied. All right, so then use the fitted model for prediction. Okay, this is just a tweaking step. Some people want to tweak their models until they get a very good accuracy, okay? But I think this will be, this process here can be just like one process, but trying to see how the flow of things, this is how it will give you some guidance. So this is just testing the model and then trying to update it, maybe to perform better if it was performing poorly, and then you use the model on like new data to see what prediction is it going to give you. Then the output. Every output that the model provides, along with new data that facilitates the output. So every output that the model provides, along with the new data that facilitated that, the output becomes a new input-output combination that is fed as training data into the model for learning. So like, this is just saying that after you've given it like a new set of data and then it has given you a prediction, now that is also going to be a new learning point where it will have inputs and now the outputs, okay? So really the point of this graphic is to show you the process you go through: data preparation, choosing an algorithm, fitting a model, choosing a validation method, and then getting the output. So in summary, we can say comfortably in supervised learning, learning comes from known label data to create a model, then predicting target class as output for a given input data. Supervised learning is also known as data mining task, and it's used for inferring a function from labeled data. Let's take an apple as an example for this learning process. Let's assume we have a fruit basket and we call it our fruit, we call it as our fruit basket. Now pick an apple from the basket below, from our basket below, process at a, now Now to pick an apple from our basket below, process at a higher